Hi, in this video I'll be talking about how do we import data into Matlab. The first function we can use to import data into Matlab is the load function. You can use the load function to import ASCII types of files, but the ASCII types of files that is consistently sized and there are no other symbols within the file. Let's start off with an example. Here you see that I have two text files. I can load them into Matlab by using the load function. Let me assign the data within the ASCII files to a variable called x with the load function. Open it up by the apostrophes, the name of the file, close apostrophe, close parenthesis, and press enter, and the data will be loaded into my workspace named as x. Let's try another file. Y equals to load test2.txt, and I'll get an error. Why am I getting this error? Because if we preview the file using a text editor, let me navigate to the file first. You can see that the data is not consistently sized. There's one missing value in this data file, which will give you this error if you attempt to use the load function. How about if you like to load data from an Excel file? Let me just create a dummy Excel file. Name it as the same variable as same numbers as just now. I'll save it. I'll put it in the same working directory as just now, so I wouldn't have to search for the path of where the file is. I'm going to name it as workbook. Why don't I just name it as test Excel. Notice that the extension is xlsx. And close this file. And let's try to use the same command. Test Excel equals to load, then the name of the file, test excel.xlsx, close the apostrophe and press enter. And you notice that you're not able to import data from an Excel file. But what to do if you have data in the Excel format and you like to import it into Matlab for analysis? So what you can do is just open up the file, and you, instead of saving it in the XLSX format, you save it in the CSV format. So you can do that by choosing Save As, and in the file format drop-down list you choose comma separated values and click on Save, and now it's in a CSV or .csv file format. Close this file, save, and we try it again. Test Excel equals to load apostrophe, the name of the file, test underscore Excel. There, you're able to input the data. Now, what if your file that you would like to import the data is not within the working directory of the file? For me right now, the working directory is in this IEA216 folder. So let's say it is in a folder within IEA216. So let me just create a dummy folder. I'm going to put this test Excel file, CSV file, into this dummy folder, and I'll try to load it again. So I'm just going to name it as Z equals to load test Excel dot CSV. You say that no such file or directory is found within that folder because we placed that file in a folder within this IEA216 folder. So what we need to do is we need to navigate to that path of where the file is. So what you can do is type in the same command, so load, and then because it's a folder within the same folder, we can just type in the name of the folder, dummy, and then the name of the file, close parenthesis. There you have it. You'll be able to import the data. So you can use this method for any file located in any place in your PC. You need to navigate to that folder by using the /. Let's say the file is in the desktop folder. I'm going to put this file into my desktop. I'm going to attempt to load it again. So say A equals to load. Now I need to navigate. So for me, I need to put in, let's see, let me remind myself, what is the path? pwd, okay, users and so on. So x, z equals to load, and type in users, and that's me, u3, and it's on my desktop. The name of the file, close, there. You'll be able to load the data from any location in your PC. What are the advantages of using load? One is that load works for simple and unstructured code, like what you saw just now in the example. Number two is that it is powerful and easy to use, but it is quite limited because the data has to be consistently sized, and it can only include numbers and not symbols or characters. By using load, it will force you to manually handle the data. Keeping that in mind, there are many other functions that you can use in Matlab that are more complex but then are way more flexible. Let's try to use a method to import data into Matlab that is more flexible. To do that, we are going to use a family of f function, which includes the fopen, fclose, fseek, ftell, frewind, fscanf, and others. The general procedure is to first fopen the file, and then to import the data into Matlab using the fscanf, and then to close the file. To start off, we should create a text file, a simple ASCII file with data in it, and use that file to import data into Matlab. So I'll just create a file using the text editor. So let's say it's a simple data file of just numbers 1, 2, 7, 8, and 9, 10. I'm going to save it as, I'm going to put it in my working directory. Documents, Matlab, IEA216. And I'm going to name it as test data. Click on save. So now I've created my test data. How do we import this test data of those numbers into Matlab? So we're going to use a script to do that. Create a new script first. And like I mentioned before, we start off with the fopen. So we need to identify the file and associate the file with a number that points to the file. So let's call that a file ID. It could be any name that you like, equals to fopen, and the first argument is the name of the file. So within quotes, we write the name of the file. Because the file is already in my working directory, so I can just type in the name, testdata.txt, and close it. And by running this, you'll be able to, oh, I forgot to put the semicolon to suppress the output, and then the warning will go away. Now that we've associated this file to a number in Matlab, and Matlab will use this number to refer to the file. Now since the file has been opened, now we can import the data into the workspace or into Matlab. We use the fscanf function, and we're going to put it into a variable called test data. Maybe just test. Okay, so equals fscanf, and this is where we're going to use this variable that we declared that's associated with the test data.text. So file ID, comma, and then what is the value that we expect to import? So we know just now that the values are just integers. So integers in Matlab is defined as, okay, quote first, %d, close quote. So this stands for integers. We expect integers to be imported into Matlab, comma, and we saw just now it's a 5x2 matrix of data. So we can specify the rows and the columns by writing here 5, 2, close, And by now, and suppress the output, and by now, if you run this, then the data inside this test underscore data would be assigned to this value test. And then don't forget to close the file. So if you run this, we have to save it first. So let's call it test data import. It runs, and as you can see, the test has been assigned the values within the test underscore data.txt file. So just to view it, I can just type in test and I'll see the data. But you notice here that the data is a bit different than what we expect it to be. If you look at the original data, it's arranged in this way, but over here it's 1, 2, 3, 4, 5, 6, and so on. So let's say you did get to import data into Matlab, but then it mangles your data. It changes the orientation of the data inside when you import the data. So you have to play around a bit with how you get the data into Matlab. So here, one idea I can give is to import it into this 5 columns first, and then goes to the next column. So if I put it as 2, 5 here, and run this, and take a look at the data, you see that it is half of what we want, what the original data looks like. So to put this back into how it is in the text file, so we can just transpose it. We'll just use the function. And once you transpose it, then it would be in the same orientation as in the original text file. There. Now I would like to talk about the fseek, ftell, and frewind functions. So let's try the file import, data import again, but using the command window. Same thing as just now. File ID equals to fopen. Okay, the file is associated with the number 33. Then we import the data into, let's say, test1 variable fscanf file ID, which is the number 33, and the number we expect to import is a number, is an integer in the form of 2 rows and 5 columns, just like before. Press enter. Okay. Now let's say I would like to re-import the data into test1 again. What would happen? Using the same command, import the data into test1. What happens is that test1 will be empty. There's no values inside, and you might ask yourself why, because just now the line before we'd be able to import the data, no problem, but in this line, right after that line just now, the test1, or the variable you import data into, there's no error, but the data itself, the test1 variable, contains no values, as if there's no data in the file, the text file. What is actually happening is, if you import data, you have already moved the pointer in that file. Every time you open a file with this command, you set the pointer to be at the beginning of the file, and as it scans through the file, the pointer moves from the top to the bottom, and it stays there. So if you try to import again without moving the pointer back to the beginning, then it's going to see that there's nothing left to import because it's already at the end of the file. So just to confirm that, let me show you where the pointer is at now. We use the function ftell and type in the file ID. You see that the pointer is at the 20th position. So let's compare that when we first open the file with this function. File ID equals to fopen. And check ftell. Where is the position? It's at 0. Once you import the file, check again. It's at 20. So that explains why you're not able to import any more data after the second line, because the pointer itself has moved to the end of the file. So let's say you can reset the pointer by closing the file and reopen the file. So let's say you wouldn't like to close the file using fclose. you still want to maintain the connection, still have the file open, but just to move the pointer back to the beginning. So how to do that is by using this function frewind file ID, and let's check where the pointer is now. It's back at 0. Let's try working with a file that has headers in it. What I mean by headers is, looking back at the test data, usually we have columns of data and we have a row at the top that explains the contents of the columns. So let's say the header of the first column here is x1 space, and the header of the second column is x2. Close this. So now the test data has become a combination of headers, characters and numbers, and also the data after the headers. So how do we import data in this case? Because you wouldn't want to import x1 and x2 as actual data, because it just explains the contents or gives a name to the column but not the actual data itself. So let me close this first. Let's import the data with the headers using a different script. So again, we always start off with the file open. Let me clear the workspace and the command window first. Okay. So we start off with file ID, maybe file ID 1 now, and fopen test data text, and then we import the file just like before. And then we will close it. Let's try using the same method as just now and see what happens. Save it first as header. Oh, I forgot to assign this to a variable, so let's call this test again. So let's look at the results of test, the values inside the variable test. It's empty. Why is it empty? So there's no problem with the pointer because we open it and we close it, so by right it should start from the beginning. But the reason why it's empty is because the Matlab is expecting an integer to import, but what it receives, what it saw in the file is a character x1. So we can import the headers as well, but it's better if we skip the header row and just go to the first row with the data. So that's when the pointer will become useful, to skip certain sections of the file so that you don't have to import those sections and import the ones that you want. So we need to make some modifications here. We need to add some more commands. We use the fseek function to change the position of the pointer. So fseek and then the file ID, and where do you want Matlab to start importing data. So here, looking at this, if you want to go to the second row, how Matlab will import the data is from left to right. As it goes to the end, it comes down to the bottom and goes to the next. So we want to exclude x1 space x2 and go to the second row. Okay, for each character it uses 1 byte, and for a number it uses 2 bytes. So here we have 1, 2, 3, and then space, there's no bytes, 4, 5, 6. So the next entity that Matlab would encounter is the number at the 7th place. So again, 1, 2, 3, 4, 5, and 6. So the 7th. So the offset should be at the 7th byte. And the origin is at 0. So now with this command, it will move the pointer from 0 to the 7th position, and at the 7th position is when Matlab will start to import the data. So let's try this. There, you see? It has imported data, but there's a missing value here. Let me just take a look at that. It's missing the number 1. So I think I offshoot by 1 position here. It should be at the 6th position. Yeah, if you look back at the data, it's 1, 2, 3, 4, 5, 6. So after 6 is when it will start to import the data. So let's run this and take a look at the data. Yes, that's what we like, and just to arrange it like how it looked in the text file. So test is test transpose. There it is. So we looked at data that consists of integers, but what if the data, well, most data is in a decimal form. So let's make some modifications to this test data file. Let's change it to a decimal, like say 1.1, 2.11, 3.4, just some random values. And save it, close it. So let's try to import the data, but still maintain this %d for integers. What will happen to the data that you import? Click on run. So you see that the data is still in the integer format. If you like to import the numbers with decimal point, then we use this simple %f, which f stands for float numbers. If you click on run here, and take a look at the data. There, now it becomes numbers with decimal points. So that is how you import data into Matlab, and I'll see you in the next video.